Hello and welcome to the session on Python recursion. Today we're going to learn how a Python recursive function is made and what it means. So first let's see what recursion is. Recursion is a process of defining something in terms of itself. So you're referring to your own self in your definition. That is, in a nutshell, the definition of recursion. Now you know about Python functions, and you know that whenever we want to use a function we have to call a function. So a recursive function is one which actually calls itself, and one of the most popular examples of a recursive function is the function for a factorial. Let's take a look at how we can implement this function. So here we have the code for a recursive function for a factorial. We are defining the function here, factorial, and we're going to pass it a single number which will be calculated and then return to us as a factorial. Now if you can look at the code segment here, I want you to focus on this part first. So you can see that within the body of the function we have called the function itself. So this function is going to call itself again and again and again because it repeats, because when you invoke factorial it's going to again go into the body of this function and again call itself. So every time we call factorial it's going to call itself again. Now this can result in a situation of infinite calls. So we have to provide a way out. We must tell the function when it should stop calling itself. So this is done by putting it, in our example we have put it in a else condition. So as long as the number that is being passed as an argument is not 1, the function will call itself. Otherwise it won't. So whenever we pass a number, say we passed a number 3, then the first thing the function will do is it's going to check whether we have passed it 1 or not. So if you have passed it 3, it says okay, you have not passed me 1, therefore I have to go to the else part of the loop. Had we given it 1, it would have just returned 1, the same thing. Now because it's gone to the else bit, what it's done is it's going to return x, which is the number we have passed it, 3 in our case, multiplied by a function call to itself with one number lesser. So it's going to call itself with 2. So now when it calls itself with 2, again it's going to check, is it 1? No, it's not. So it's going to call itself again, 2 in this case, multiplied by factorial of 1. So now it's called itself again with the argument of 1. This point of time it's going to stop. So let's run the function first. We're going to pass it 3 to begin with and see. So the outcome is the factorial of 3 is 6, which is 3 into 2 into 1, which works. But let's see what's exactly happened inside the function with the call of 3. So when we said factorial 3, it made the first call with 3, but then the second call from within the function was 3 multiplied by 1 less. So 3 into factorial of 2, it had to reduce it by 1. But the moment we say factorial 2, it's going to make a second call because we've called factorial now. This time it'll say factorial of 1. It's going to call it with 1 less number. So this part, factorial 2, unpacks into 2 multiplied by factorial 1. When we call it with factorial 1, it's going to go into the first part of the conditional where it's going to check whether we've given it 1 or not. And it's going to come to the conclusion that we have indeed passed it 1. So the recursion will stop here. And from this point it starts returning reverse. So now factorial 1 is going to return 1. If you can look at the code here, the moment we get 1, it's going to return 1. So factorial 1 is now going to evaluate to 1. This is evaluated to 1. Then this outcome is returned to the second call. Goes like this. Then it's gone to the third call, or the first call, the outermost call. And finally it's going to end up with 3. So when we are calling the function recursively, initially the function keeps calling itself with one lower parameter, but when it hits the base point, it starts returning in the reverse order. So internally this is implemented using a stack structure, and for that reason one has to be very careful, because if there are too many recursive calls, a lot of memory is going to be used. It's important to understand that in a function, normally when we say a function has been called, then whatever variables have been defined within the function are destroyed as soon as the function call is over. So even if you have 10 variables within the function, as soon as the function returns something, all those 10 variables that existed within the function are destroyed. But in a recursive function, that is not the case. So a recursive function is going to hold on to every single variable till the entire duration of the recursive call is over. So if the recursive function ends up calling itself 100 times, then all those 100 calls will have the entire set of variables stored in memory. So it can become quite memory intensive. So that is one of the disadvantages of using recursions. The advantage is that you can use a very few lines of code and make it really neat and clean. Now let's take a look at what happens if we do not tell the recursive function when to stop. So this is a really simple example. We're defining a function called recursor. The only thing that this function is doing is call itself again. So let me just separate this out. Within the body of the function, there is only one thing happening, and that is a call to itself. So when we're going to call this function, there are no arguments. It's going to enter this part, call itself again, enter this part again. So it keeps on looping, and there is no way out because the function doesn't know when to stop recursing. What happens when you do this? As you can expect, it's going to return an error call. Let's take a look. Let's see what is the nature of the error call. So it takes a bit of time because it's running through a lot of recursions, and towards the end you will see that the maximum recursion depth has been exceeded. So Python defines within itself internally that this is the number of iterations I'm going to do before I call it a day, and by default it's going to be 1,000 iterations. Right, so this is about recursions. We've already discussed the advantages. It makes your code clean and elegant, and you can break up the code into simpler subsections. The disadvantage is that it's going to be really memory intensive if you have a lot of variables going on. Also, recursions are not very easy to understand and explain, and if it's a complicated recursion, you may find it hard to follow the logic. This can be a problem if something breaks down. So that's it with recursion. Thank you for watching. I hope you enjoyed this video, and I'll see you in the next one.